Last week I talked a little bit about um, uh, science, physics, what physics is about, and some of the things that we require people who come here and question, some of the things we propose here, theories and so on. And, let me start with this. I think it was in the 70s, like 50 years ago, there was a movie, A Thousand Clowns by Jason Robards. And I thought that was a good title for what I'm going to be presenting here at the beginning. I seem to have a bunch of clowns come over here lately, and they want to challenge, the rope model and the version of science and the physics that we have here. And no problem, we have no problem with people challenging that. But like I said last week, you need to know what this channel is about and what you got to do to counteract what we say here. And these people don't seem to understand that. I've tried a couple times now already. They don't seem to get the message. They keep insisting that they can get away with democracy. Everybody votes for a given theory or whatever, or definition or whatever. Authority. This is what they told me in school, and so I just memorized it, and so I just regurgitate it here. Or maybe they go to a dictionary and just pull the definition that they found there. They don't understand it. It's irrational. They don't care. They just bring it in. Or what's the other one? Tradition. We've been doing this for 400 years, since the days of the 17th century revolution, and so we're not going to change, what we've been doing. And, the issue here is that from the mathematical establishment, no one can tell you, something as simple why this pencil, I get smaller and smaller the pencil, why this pencil falls downwards. They cannot tell you that. Not one person, 2,000 years, 3,000 years, no one can tell you why that pencil falls to the ground, not to the ceiling. Simple things like this. And they are very, very, extremely simple. And they can't answer those questions. And part of it has to do, with definitions, the fact that they never define words. We don't have rational definitions in all of mathematical physics, so-called science, we don't have them. Nobody ever dedicated time to that because they think that's philosophy. And so they leave the philosophers, they leave it to them, or to the English majors or ontologists or metaphysicists or whatever they call them. And they say, hey, you define the words for us. So we have people outside of the discipline of physics defining the words for physics. And of course they don't care, and the other guys just use it, and so that's where we are today. We don't have definitions. And so here we introduce a little bit of authority. You want authority? Here you have authority, okay? You have good old Juanito Baez, okay? And he created the crackpot index. Point number 14, 10 points for each term you use without properly defining it. Okay? You must define words, the critical words, the ones that make or break your theory. You have to define those words in science and in physics. Okay? And if they're misdefined, we're going to have problems. We're going to have first problems in communication and also in you developing your theories. And I'm going to show that in a minute. But we need to define words in both science and physics. These people don't want to do that because they say, oh, that's semantics. That's rhetoric. That's, that's word salad. For them, it's just noise. And no, you need to define these terms, the ones that are going to make or break your theory. And so here's the first word that we want to define, so that you get an idea what this site is about, okay? And that's the word science and the word physics. We need to know what science and what physics is. Now, if you don't like these definitions, you got a better definition? Hey, no problem. We challenge you to bring them over. But please don't bring the nonsense you'll find at the Wikipedia or in the dictionary, because those are trash. We have no use for those definitions. They're not valid definitions. They're not rational definitions, okay? So if you get some other definition, a personal definition that you want to bring in, that you thought about, you crunched it really good, and you want to bring it over, hey, please, we want you to bring it over, okay? So let's make sure we understand that much. Okay, so here it is. This is science, rational explanations, okay? Period. Rational explanation. That's what science is. If it's irrational, it's not part of science, okay? And that includes all of mathematical physics. None of that is rational. Physics, what is that? Well, it's a branch of science, and it's rational explanations of what? Of causes and mechanisms. That distinguished from philosophy, which is rational explanations of purposes and reasons. So now we have a definition of science, physics, and philosophy. Physics and philosophy being branches of science. And those are the only two branches. Then there's all these sub-branches underneath them that you see there in lighter color. Okay, so what is a physicist? It's an individual who rationally explains causes and mechanisms underlying phenomena. Okay? What is irrational? Well, here's some criteria. Okay, using concepts as objects, that's the main one. You know, mathematical physics is famous for using all concepts as physical objects. We'll go over that today. Explaining without defining key words or using them inconsistently, and explanation does not follow from the assumptions. Unimaginable mechanisms, you know, there's a couple more, but those are the main ones, okay? What is an explanation? Well, it's a reply to why an event happened in physics, okay? And so, yeah, it's the, you have to tell someone the causes and mechanism behind a phenomenon. That's what an explanation is. So we got the definitions in place. We think they're rational, they're consistent, they're comprehensive. You don't agree with them, we don't care. We don't agree in science. Agree has to do with religion, with opinions. We're not asking for opinions, we're asking for objective definitions. You have a different definition, put it up there and we'll talk about it. Okay, so that's the first one. People should understand what we propose here as far as science and physics. Okay, period. What other words do we define? Well, if you're going to do physics, you cannot be able to explain a mechanism. You cannot give a physical interpretation. You cannot talk about the causes unless you define these words. These words are sine qua non. Okay, so if you never define these words, you're not a physicist. Okay, if you don't understand the meaning or the significance of these words, why they're important in physics, then you haven't gone through kindergarten physics. That's how simple it is. Okay, and here it is. These are the foundations of physics. That's what we call them. They have nothing to do with philosophy. They have nothing to do with ontology, epistemology, etymology, word salad, word wizardry, any of those. These are the foundations of physics. You need to have these words if you want to give a physical interpretation, which is 100% of what physics is about. Physics is not about math. Physics is not about predictions. Physics is not about, fields and energy and all those words they have. It's about physical interpretations. That's what it is, okay? And so there you have the words. First of all, we say, again, physics are rational explanations of causes and mechanisms. The golden principle of physics, if you're going to explain a mechanism, you absolutely need what? An object. You can't do physics without objects, okay? So physics requires an object. And so one of the first words, at least, or maybe the first word you have to define is the word object itself, okay? That which has shape. It's not that which we can touch. It's not that which we can see. It's not that which is made out of matter. Or volume or mass or any of those. No, it's that which has shape, okay? It's all objects in the universe have shape, okay? Not all objects can be seen or touched specifically. Space, the opposite of object. If object is a thing, space is nothing. Okay, it's the antonym, it's the opposite. So if one is that which has shape, the other one is that which doesn't have shape. Distance, we need to have the word distance if we're going to talk about physical interpretations. Any physical interpretation, either you specifically mention the word distance or indirectly you bring it into the discussion. Okay, so there you have it, distance, separation between two objects. What is location? The set of distances from your target object with respect to all the others in the system or in the universe, whatever you are going to be, whatever your dissertation is about. Exist, very important word in physics because physics is the science of existence. Okay, so it's a specific science, the science of existence. the word exists does not belong to ontology, to philosophy, to epistemology, to metaphysics. It belongs exclusively to physics. Okay, only physics deals with the word exist. Anyone wanting to have a discussion about what exists in the universe, whether they know it or not, they cross the line into physics. So you're going to talk about the existence of God, the existence of this chair, the existence of your mother. You cross the line into physics. Okay, now you have to define that word exist. Exists physical presence, which requires an object plus location, which we have just defined. And then motion, obviously, two or more locations of an object. Finally, concept, a word that invokes or embodies two objects. There we have it. Okay, so those are the definitions we propose here. We don't care if you like them or not. We don't care if they destroy your religion. Especially what we want is for you to define those words differently if you have different definitions for them. And if you don't, well, then you have to bow down to this. You have to live with these because these are not only comprehensive, one depends on the other, but they are also rational. You can use them consistently. And so here's the words that mathematicians need to define. Whoever wants to challenge those, these are the words you got to define, okay? Object space, you can say something, nothing, okay? Distance, location, exist, motion, and concept. Those words form the foundations of physics. What is physics? Physics is not math. Physics is not, doing experiments, tests, or whatever, verification, falsification, prediction. None of that has anything to do with physics. Physics, rational explanation. We don't care if you studied all year, if you went into the lab and measured and all that kind of stuff. We don't care. When you come to the conference, we want you to explain. What did you learn? Don't tell me that you ran a test, an experiment, and that you measured. That has nothing, and that you have predictions. Who cares about that? What we want is an explanation. Explain the mechanism. We need to know how Mother Nature runs her shop. Father Universe, God, the devil, whoever you believe in. Okay? So we need to know how this universe works. That's what physics is about. Okay? And when I say how, I mean why. In other words, we're looking at physical interpretations, whys. Okay? We want the whys. Okay? That's what a rational individual wants. He doesn't want a description. Okay, so here are some of the rules. Okay, scientific rules for definitions that we propose here. The first one is not mine. It's from a fellow from Texas, a friend of mine. Don't whine, define. I like the other one that I use, and that's can't define, can't use. Okay, just that simple. Okay. This is not philosophy, ontology, metaphysics, rhetoric, linguistics, semantics, word salad, etymology, epistemology, and all knowledge or any of those. Okay? These are the foundations of physics. If you cannot define philosophy, ontology, metaphysics, or any of the others, then you cannot use these words because they are vacuous words. Okay? You are simply using words that you don't understand. You can just replace those words with the letter X, Y, Z, and we're in the same situation. We don't know what X, Y, Z is, okay, what it means. So you are not allowed to use them in science or physics if you cannot define them. Can't use the arguments of democracy, authority, or tradition to defend yourself. Oh, that's the way we always done it. Oh, all the boys at the math club voted for this, and this is how, my teacher taught me, or this is what I found in the dictionary. Authority, no tradition, no democracy. Okay? So none of those you can use none of those to defend yourself. You want to defend yourself with rationale, with reasoning. Reason your definition. Okay? Don't tell me that that's what you found in the dictionary and that's what your teacher told you. Okay, so that's the first one, definitions. The second major point, at least that I made last week, and I just want to regurgitate that a little bit, is that whoever comes here has to tell us what the invisible, intangible mediators that Mother Nature uses to do her daily work. And Father Universe and God and all these other fellows, right? What do they use? Here you have a pencil, okay? And once again, I let it fall down, okay? Always falls to the ground. Don't believe in me, you can run your test at home, whatever, right? We know that things fall to the ground, and they fall towards the center of the earth, essentially. And the question is, why? Why don't they fall upwards to the sky? And so the issue is, whoever wants to talk about gravity or light or magnetism, how a magnet attracts another, what electricity is, what an atom looks like, how it does its quantum jump, and all this kind of stuff, any of those things, you have to tell us what the mediator is. Don't tell me that entanglement, this particle affects that particle with nothing in between. That's called black magic. That's called witchcraft. That's voodoo science or voodoo physics. No, if this object affects that one, there's something connecting them. Okay? So, you need a mediator. And that's where the problem is. These people have always worked without mediators. And what they did, they substituted the mediators with abstract mathematical concepts such as field, energy, time, mass, etc. Okay, so this is where the problem is. And so here we go one at a time here. Here's light, okay? And this is what these fellows came up with. You recognize some of them up there. And what you see is what is known as an electromagnetic wave. What you're staring at is what you see there in writing, and that is an electric field, a magnetic field. And what are those? They're made out of all those arrows, and the arrows are numbers, known as vectors. So you have numbers, known as vectors, magnitude, right? And they make up the fields, which are also a value at each point in space, more numbers. So what you're staring at is a bunch of numbers being pictorially depicted, with arrows. And at the bottom, this scary thing where you see all these arrows, these numbers, and they're moving towards the right. So this is what they've shown us for now 200 years. So this is nonsense. You can't use the wave because there is no such thing as wave. Wave is just a bunch of vectors, okay? That's all it is. And other people say, hey, it's particles. And here you have particles. And we have a problem with that also because, they're not particles. In other words, they're not the corpuscles that they used to have in the days of Newton or Huygens and all these other folks, right? No, what you're staring at are corpuscles, and quantum has gotten rid of that. They don't use corpuscles. Everybody simulates them, everybody depicts them as corpuscles, but they're not corpuscles because quantum doesn't believe in corpuscles. They call those corpuscles classical mechanics. Quantum has magical particles, okay? They're not talking about particles. The word particle stayed over when it shouldn't have. They're talking about concepts. They're talking about energy. They're talking about frequency or whatever. They're not talking, or charge, right? They're not talking about physical objects, okay? They're talking about concepts, and they start moving all these concepts around. That's why we need to define the word concept, separate it or distinguish it from what an object is, okay? Those two are not the same. They're not synonyms. And more ridiculous one that they came up with is this one. What's going on here? Why can't I see this? I guess. Oh, I see. Hold it. Give me a second. There we go. Okay, so this is the quantum packet, wave packet, and Roger Penrose puts it in his book. It's called the wave packet, and you see that curlicue there, and that's what they show you, and they say, light, it looks like that. Well, we don't know what that is. Well, what is that? Is a standing wave of what? Is it a rope, a string, a cable? What is it that's waving up and down? Okay, so, you can't come up with this nonsense because you got to tell us what we're staring at. You can't say that's a wave packet, whatever that means. Okay, so we need an object. Okay, so whoever wants to talk about light has to bring an object. Tell us what is the mediator of light. And you have some people out there, they say that it's the waving of nothing. Yeah, sure, tell me about it. Gravity, here's another one. We have a spoon, falls to the floor. And we've seen this constantly, right? We all know that things fall to the floor. Okay, so some people say, well, it's pushing, we have these pixies pushing from above. Okay, so this is their theory. Okay, so this is what they propose, that the pixies or particles or whatever push from above, and that's why the spoon falls to the floor. Okay, we have problems with that, but you're welcome to bring particles if you can explain the mechanism, and you're going to have a lot of trouble explaining the mechanism because why don't the what is it, pixies or particles push from below? You know, what about the particles coming from the other side of the universe, from below or from the sides of the Earth or whatever? So you're going to have a hard time explaining, you know, this we all understand. Particles pushing this down, we all understand that. And the only issue here is, you know, how do you explain the mechanism when you have particles from every direction? Okay, so that's what you would have to explain. And others do it with with a wave here. Okay, so the particle falls because, you know, there are gravity waves. And I don't know what the mechanism there is. You would have to explain it to me, but some people talk about gravity waves. And that's what I'm trying to simulate there. I don't know. I don't want to, you know, debunk anybody here. I just want to show what they say. They say gravity waves, and I don't know how they explain that gravity waves compelled the spoon to fall downwards, okay? And then we have something even worse. We have these warp number lines. You know, this is what relativity proposes. They say what's happening is that when the spoon falls, you have these number lines. Those are the white, you know, lines that you see there. Those number lines, they bend. And so, you know, that's not a physical object that you're staring at. What they did was replace number lines with a net, with a fish net, a canvas, and gives a misleading impression that you're looking at a physical object. You're not. What they have is a description, a mathematical description, and that cannot substitute for a physical interpretation. And then obviously we have our model here, and let's see if I can get it in there. Here it goes. And we have the spoon. Every atom of the spoon is bound to physically bound to every atom on Earth. Every atom on Earth is bound to every atom of the spoon. And so as the spoon approaches the center of the Earth, the ropes fan out. And that's why there's an acceleration. So that's our model, okay? We don't ask you to like it. We don't want you to say you love it, that you're going to believe in it. We ask you to understand what we're saying. Just understand it. That's it. And then you can go to your own home and reach your own conclusions, okay? So again, science is not about belief, about opinion. We don't care about if you vote for it or against it. None of that has anything to do with science. That's got to do with religion, with what you believe in, okay? So we don't care about that, not in science. Okay, here's magnetism. Again, we need mediators, the invisible, intangible mediators. And what the mathematicians usually say is that, you know, you have the electrons from each side, from the south and the north side, and they're spinning somehow, and no problem. Okay, so the electrons are spinning. Great. And how does that produce attraction from far away? Okay, so if the electrons are spinning in the north and in the south, how does that produce attraction? We need the mechanism. Okay, don't tell me that the electrons spin and that you measured and you've got the proof and evidence and you can predict. We don't care about any of that. We want the mechanism. How an electron from one side, one magnet attracts an electron from another magnet. What is the mechanism? Okay, don't tell me that they do. Tell me what the mechanism is. Okay, that's what you got to do. I mean, this is not for you to say, hey, we measured, and, you know, the great scientists at Harvard and Cambridge, all these people, they measured and they've got the exact, they have precise values, and here's the equation. No. We need the mechanism, okay? Give us the mechanism. That's it. Yeah, that's physics, okay? The rest is mathematical nonsense. Okay, electricity, more or less the same thing. This is what they show you. They show you that electrons, what they call charges, they move around, okay? And they are negative, so they go to the positive pole somehow, whatever that means. We don't know what positive and negative is, so you got to explain that in physical terms. You can't say negative goes to positive, okay? That doesn't tell us anything in physics. Okay, but we have a problem there because, you know, those electrons, why are those electron beads moving from atom to atom? You got to explain the mechanism. What compels them to move? Okay, I mean, even if you remove an electron from one atom, why would another one fill its space? Okay, what's pushing it out of its own atom and, you know, filling the hole that the other one left. So you got to explain that. You got to explain the mechanism. Don't tell me it does that. We've verified and we've proven and we can predict. We don't care about any of that. You got to explain the mechanism, and that's where mathematical physics fails completely. They've never been able to explain this. They just say it is so. Okay, and here's the vacuum chamber, just so you can see something here. They got rid of the atom. In other words, they got rid of the nucleus of the proton and the neutrons. What they have is just electrons going, across the space. They say, oh, it's just a flow of electrons. Yeah, so it's not that they go from atom to atom like you see on the top. It's that the electrons are flowing without any atoms. So they have electricity without atoms. Yeah, just like I say. So that's the new version or the latest version. And so you got to explain the mechanism. I don't care. Before you can explain that, you got to explain this other one, which is the quantum atom. Okay, and here it is. The quantum atom is just a bowling ball and a golf ball. Okay, that's it. One is called the proton. The other one's called the electron. One is positive. The other one's negative. Whatever that means, we don't know. But the question is, why don't that electron B just fly away, or why doesn't it fall to the bowling ball if the bowling ball not only is bigger, more massive, right? They have the same charge allegedly, but why doesn't it fall to the positive bowling ball if positive attracts negative? Why doesn't it get stuck there? And why doesn't it fly away? I mean, that's what you got to explain. Without that, you don't have an atom to explain anything. Okay, so you got to start with the atom. And here's essentially what I'm referring to. You have the electron bead, blue, going around the center where you have the 3 quarks that make up the proton. Okay, and as you can see, the electron just goes around in circles from orbital to orbital or energy level to energy level for whatever reason. And for some reason, that electron doesn't go all the way to the center, and at the same time, it doesn't fly away. Okay, it just sends its energy out, whatever that is. So we have a problem with what these people propose, because none of that is rational. You cannot rationalize what these people are saying. There's no reasoning to it. Okay, so this is the problem. Okay, so now you know what you got to do. You got to define the terms, and you got to tell us what invisible, intangible mediators, Mother Nature and Father Universe and God the Devil, use to do their daily work. And once again, let me show you proof, evidence, prediction, falsification, the whole works here, right? We're going to let go of the pencil, okay? And it falls to the ground, right? And there's nothing here and there's nothing here, nothing that I can touch or see. So whatever is pushing or pulling this to the ground, okay, is invisible and intangible. Invisible, intangible. Get that through your head. It's invisible and intangible. You cannot touch whatever's here. You cannot see it. Okay? And so what's the issue? The issue is that you cannot say, hey, I went to the lab and I ran an experiment. What? What did you use? Did you use your eyes and your hands? I mean, it's invisible and intangible. So don't come back and say that you saw it, you touched the mediator or whatever. You will not see, you will not touch the mediators. You have to conceptualize it. You have to visualize it. Close your eyes and visualize it. What they call armchair physics. That's physics. You have to tell us how this universe works. For that, you have to visualize what Mother Nature could be using, because we will never be able to see or touch the mediators Mother Nature, Father Universe, God, the Devil use.